Alright, for the next question, you see that the angle of inclination now of the vectors, which the vector I'm using in this case is force, because see the unit there is Newton. So the angle of inclination is now 60 degrees. But again, we're going to, first thing first, we'll complete the parallelogram, remember. Now, the resultant is always the diagonal of the parallelogram drawn from a common point. Now, the next thing to do is to consider the direction of the resultant. So you see that this 3 Newton is going in this direction and the 4 Newton is going in this direction, right? So the resultant must also be going in a direction that combines two of them. So it will be going, in this direction. So let me just get rid of that one. So it will be going in this direction. So this will be the direction of the resultant. So we can call it R as usual. So this is what we're looking for now. Remember, we're looking for the magnitude and the direction. Now, you see in this case now, this is not a right angle because this angle here is 60 degrees. This one here will also be 60 degrees. Remember, opposite angles are equal. So this angle is 60 as well. Now, we don't know the value of this angle, but we do know that it can't be 90 degrees, right? It can't be 90 degrees, so it's not going to form any right angle whatsoever. So we cannot use Pythagoras theorem. So in this case now, we need to use the cosine rule. That's what we're going to use because we're looking for R, and then we need to find the value of this angle. So we need to find the value of this angle in order to use the cosine rule because we must have the angle that's opposite the resultant. Now, how do we find this angle? Well, you remember what I said, that this 60 degrees, let me just highlight it, this angle 60 and this required angle we're looking for, they are not equal but they are supplementary, if you remember. So we are going to say that 60 degrees plus that, let's call that angle alpha, for instance, it must be equal to 180 degrees. So alpha is equal to 180 degrees minus 60 degrees. So that angle is 120 degrees. So this angle here is 120 degrees. So that's how we found the value. Now the next thing, we're going to use the cosine rule, right? So I'm just going to rewrite the cosine rule. We have c squared is equal to a squared plus b squared minus 2ab cos theta, and the theta is the angle opposite c. In this case, our c is r. So let's replace. We have r squared is equal to a squared. We can use 3 as our a. That's 3 squared plus 4 as our b minus, I like to put this in a bracket, 2 times 3 times 4 cos 120 degrees. So cos 120 degrees. So that's what we have. Now let's simplify as much as we can. So you see that r squared is equal to 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. So we have 25 minus, now 2 times 3 is 6 and 6 times 4 is 12, right? Sorry, 6 times 4 is 24 rather. So you have 24 cos 120. So let's just do that quickly. 24 cos 120, we have minus 12 as our answer. So r squared is equal to, see that this minus times minus is going to give us plus. So we have 25 plus 12, right? So just go down a little bit. R squared is equal to 25 plus 12 is 37. So our resultant will be the square root of 37. So what's the square root of 37? Square root of 37, we have to 2 decimal places. You see we have 6.08. So we have 6.08 Newton. Alright, so this is the magnitude of our resultant. So the magnitude of our resultant is 6.08 Newton. So let me just replace it in the question. So I'm going to remove resultant and then I'm going to put the value we found. We have 6.08 Newton. Now, how do we get the angle? The resultant makes the horizontal. So note that this is the angle, this is the direction, right? This angle here. So let me just highlight it with another color. Okay. So this is the angle the resultant makes with the horizontal. So we can call it, let's call it theta. That's what we'll have to find out, because that will be necessary to find the direction of the resultant. So we're looking for theta. Now you see that, again, this is not a right angle triangle, because let me label the triangle again. You see we are working with triangle A, B, and C. It's not a right angle triangle, so we cannot use the trig ratio. So you see, thank God we have the two equations we solved so far. So consider them side by side. You discover in this part of the equation, this one, where the angle of inclination is 90 degrees, we used Pythagoras theorem. We use the Pythagoras theorem, and then we use the trig ratios, which is SOHCAHTOA. So anytime you have a right angle, always think of using these two. Now, anytime you have an angle that is either less than 90 or greater, we're going to be using the cosine rule, right? So we use the cosine rule and similarly the sine rule. So to find that angle theta now, you see that we can use the sine rule. We can use the sine rule because we have a complete pair. We have a complete pair, which is the resultant 6.08 Newton and the angle 120 degrees. And then we're looking for this angle that's opposite the side, 3 Newton. So let's go ahead and do that. Alright, so using the sine rule, remember sine A over A must be equal to sine B over B, also equal to sine C over C, but we're working with two sides. So sine A we can use as our 120 degrees, so sine 120 degrees over the side, which is the resultant 6.08, must be equal to sine the angle we're looking for theta over the side facing theta, which is 3 Newton. So that's 3. So now if you cross multiply, let's make theta the subject of the formula. I have sine theta to be equal to 3 times sine 120 degrees, all divided by 6.08. Then finally, our theta now would be equal to the arc sine, or the sine inverse of 3 sine 120 degrees over 6.08. So we can use our calculator now to find the angle. So theta will be equal to the arc sine 3 sine 120 degrees divided by 6.08, and we have just approximate to 2 dp. So you see that 9 will become 10, and then so I have to shift to the other one, so I have 25.3 degrees. So this is the angle. Again, remember that this is just the angle the resultant makes with the horizontal, which is what we've called theta. Now to find the angle it makes from the north, remember you always subtract 90 degrees. So the angle, as you want to represent it as a bearing now, will be 90 degrees minus 25.3 degrees. So 90 minus that will give us 64.7 degrees. So we can now represent. So you see that this resultant is going the northeast direction. So see it there. That is the direction of the northeast. So we are going to say it is north 64.7 degrees east. So that's our answer. All right. So our magnitude, the magnitude of our resultant, as you can see here, is 6.08 Newton. Then our direction is 64.7, north 64.7 degrees east. So that's the direction. So you discover in these are problems we've solved, the resultant is always in the northeast direction. It's not always true, right? You can solve another question, the resultant is in the northwest or southeast or southwest. So just if you're so conversant with the topic of bearing, this shouldn't be a challenge for you. So I hope you found the video helpful. If you did, if you've not subscribed to this channel, do well to subscribe so you can always get our content, and please share with your friends.